Thank you so much for having me. It's been such a fantastic conference. Really interesting presentations so far, and really honored and humbled to be part of this. So this project is called Sticks and Stones and. It's really a research project, as Matthias mentioned, between my partner Arian Forrest and a structural engineer named Brett Schneider. I'm based in Boston. I have an office called Ultramoderne, and I also teach at the Harvard Graduate School of Design. I think maybe for some context before we begin, the three of us have been working on projects in mass timber for a number of years, both realized and unrealized, and I think this research project really came out of a reflection of this early work. I think in these projects we've been very interested in the question of scale and how we can push mass timber to go beyond the kind of domestic or multifamily scale, and to kind of transform the image of conventional wood construction at the same time. And I think something that we came to realize was a kind of ambition of the scale of the project and the kind of purity of the material of wood were often in conflict and actually masked some of the pretty interesting things that were going on behind the scenes. So one of these projects the three of us worked on together was this pavilion in Chicago. It's a thin, flat roof out of CLT, with, supported on glulam columns. In this sense, the structure was kind of analogous to flat plate construction in concrete, but translated into timber this time. Which is maybe an unusual thing to do in wood. And to do this required some kind of fancy footwork. So instead of a single layer of cross-laminated timber, there are two layers that are laminated in the field, one on top of each other, as shown in this diagram here. And in order to keep, there ends up being a lot of steel in the project, admittedly, right, where the columns come through the roof. There are these steel plates on top, and then the roof is hung from those columns. And then there's also all this reinforcing, right, these diagonal screws around the columns, and the way that those two layers of CLT are put together is also with steel screws. And so it's kind of interesting to reflect on this project because there was such an ambition to have this extremely abstract, all wood, flat plane on the bottom of the project, and to conceal all of the kind of metal fasteners and other things that were happening behind this plane. So I think reflecting on this early work, like this and other project, I think these projects often push for this image of purity. The projects really felt like they needed to be all wood. The more, the better for the environment, for architecture, and also for making these materials, let's say, more accessible to an American audience. But we felt, in reflection, it tends to mask the true nature of how these highly technological materials work in an architectural context, and how the entry of a new structural material in the market might actually allow us to rethink our material choices, not as just binary decisions, so it's not all wood versus all steel or all concrete, but to start to think about a model of complementarity between some of these materials. So this current research project deals quite explicitly with hybrid construction techniques. And what do we mean by heterogeneous construction? Of course, if you look at any kind of contemporary wall construction, although we did see some counterexamples today, interestingly, most buildings are made up of assemblies of many different materials, parts and systems. So in this kind of typical wall section, a cavity wall section, you see these many different parallel technical layers coming together, often in a parallel assembly of cladding, of insulation, of structure. And despite their assembly into a unified whole, the role of each of these layers and the materials is typically independent of the others. That is to say, they're heterogeneous as a collection, but not in the way that they might perform collectively. So this project tries to look to construction where perhaps a more complex interplay of material performance exists. By this definition, the materials employed in a particular construction take on many roles in relation to one another and to the assembly as a whole, interacting with each other in complex and sometimes ambiguous ways. So in heterogeneous construction, multiple materials may work as structure, as envelope, and ornament in ways that are non-discrete, but that in conjunction do more than any one material might be able to do on its own. So when you start digging into this question of heterogeneity, What's interesting is that it very quickly forces you outside the world of modern and industrialized architecture, where the need for standardization and calculability always push towards singular systems and into the world of vernacular architecture, where there's strong traditions of mixing wood and non-wood materials worldwide. So these, of course, include half-timbering methods in Europe, which I've very much been enjoying seeing around here. But also, so I think the first step in this process was to assemble an atlas of heterogeneous constructions where the mixing of materials is the basic framework for how we deal with structure and enclosure. This atlas included, vernacular, industrial examples, contemporary examples, as a way of very quickly juxtaposing built examples from a wide range of historical epochs, but also global cultures. And then I guess the second immediate question is, how do you make sense of the diversity of heterogeneous constructions and find common threads to build on? So one of the first exercises was to start to organize some of these entries into categories, not by materials, so not looking at like wood buildings or stone buildings, et cetera, but to start to think about categories that deal with relationships between materials. So these are some of the categories we came up with: stacks, sandwiches, wraps, fills, collages, scaffolds, that really kind of each one is a kind of almost diagram of the way that different materials might relate to one another. They're certainly imperfect categories, but it was a way of drawing together examples that cut across cultures and across time. The second step in the project was to look very closely at a smaller set of these precedents from the atlas and to start to draw through them as a way of making some of these lesser known building technologies available to us again, and to kind of challenge our contemporary way of doing things. And of course, to also look in detail how things were put together. So I'll show a few of these examples. The first one is a construction type called Kathkuni construction that's prevalent in the Himalayan area of India. And it's a building practice that's rooted in locally available materials in the region. It's made of wood and stone. What's interesting is that the two materials are dry stacked to form a structure that has a kind of surprising resistance to earthquakes. Right, some of these buildings have actually performed better or have withstood earthquakes better than some of the reinforced concrete buildings in the region, which is surprising, right? That this extremely old technology would actually, in some ways, perform better. This is a close-up where you can see that dry stacking of the wood and the stone. And it's interesting because it's almost like treating wood more like masonry, right? There's a kind of equality in the way that these materials are stacked. And of course, it has this very interesting structural performance, but it also has this beautiful compositional richness of the two materials on the surface. This gives you a sense of the way these walls come together. So in this layer, there are two wooden beams that are laid up parallel to each other with a gap that gets filled up with loose stones. And then the external and the internal skins are held together by these cross braces with dovetailed joints. So here in one of our drawings, you see the way that this assembly comes together, the kind of stacking of the material, the interlocking of the wood members, the cross braces. The drawings do something very simple. In some ways, they're very conventional architectural drawings, but they're in color as a way to kind of start to color code the different materials that come together in these assemblies. And then in this section, you start to see the kind of stacking of these two materials. What's interesting is that the wood actually makes the structure much lighter than it would otherwise be if it had just been a kind of masonry construction, which helps with earthquakes. And you also start to see there's this kind of gradient from the ground to the roof of more stone at the base and then more wood towards the top. But we're interested in it because it presents this model of working where materials really complement one another. The wood ties the masonry structure together, almost like reinforcing. And of course, what's structure, what's enclosure, what's insulation is much more ambiguous in a construction like this. Also, some of the examples in our research are these pre-modern industrial examples. Let's say these paths not taken that arose during the experimental phase of the Industrial Revolution, when construction systems hadn't been so clearly codified. One example we love is the Minier chocolate factory in France, designed by the architect Jules Saulnier in collaboration with the structural engineer Jules Log. And it's peculiar in the way that it combines a very, very thin structural iron skeleton with brick, both for kind of structural but also aesthetic effects. So you see on the left an image of the construction that's just a very thin iron frame. And interestingly, this is a building that makes an entry in Siegfried Gideon's Building in France, Building in Iron, Building in Ferroconcrete, where this project is announced as the first thoroughly consistent iron skeleton building, right? The kind of precursor to skyscrapers and so forth. Notable for its self-supporting iron frame, as well as the kind of uniquely flat facade that results from the structural system. But I think looking at this project, it's actually a little bit more complex, we think. The planarity of the facade achieved by filling the gaps in the lightweight iron frame with brick likewise means that the structural roles of the two materials are inevitably impossible to separate. So the brick lends a lot of mass and likely added stiffness to a frame that is unusually light and imperfectly triangulated. Similar to the seismic properties of early skyscrapers, the relationship between masonry and iron here is difficult to quantify, but it's real nonetheless, we think. So in some of these drawings, you see that the kind of richness of the building is not in the transition to the isolated frame, but in the interaction of the iron and brick towards the execution of multiple functions of structure, enclosure, and appearance within a single plane of construction. So I think when Gideon looks at this, I think he only sees the frame, and I think he misses actually the complexity and the totality that this building presents. Keep going. A couple more examples. This is the Djenné Mosque in Mali. Very interesting building, very large building made of mud brick, where the entire, this is ritual every year where the entire community comes together to take part in the annual repairs of the facade, which gets eroded due to annual rains. But it has this kind of very interesting permanent scaffolding on the facade. You see these palm sticks that are projecting out of the surface. It's this kind of ready-made scaffolding for the annual repairs. So it's both pragmatic, but also symbolic and ornamental at the same time. Here's a kind of close-up of the construction. It's made of these sun-baked earth bricks and then coated in earth plaster outside for a more kind of monolithic look. And of course, as architects, we're also fascinated by this forest of massive pillars on the interior, the way in which the construction and the material choices lead to a very specific type of architecture and type of space. Another example we find quite interesting are yurts, and there's many different types. But of course, they're these lightweight deployable structures for people that are on the moves. This one is an example from Mongolia, and it's based on this flexible, expandable wooden frame that in conjunction with the leather and the fabric that's kind of wrapped around the frame starts to gain some rigidity. In these drawings, you can see the yurt is kind of carefully weighted down along the edges with stones. And so for us, there's always this interesting translation of how things like foundations or windows get translated, let's say, into some of these other building technologies. Close-up of the framework, and then how the pieces might start to kind of roll out flat and be able to be packed up to be transported. Of course, I should say this is a project that started really in 2020, and I think a big driver for it was also to really try to look outside of the European and North American kind of modernist canon for fresh ideas and approaches to really address some of the most important challenges of our time. This is the last example. This one's for you, Helga. This is the longhouse by the Seneca tribe in upstate New York. And it has this beautiful construction technique that are bark panels that are sandwiched between an interior wooden frame and smaller timber members on the exterior. So it's interesting because it's not as kind of simply cladded frame like you would expect in modern construction, but the bark siding is really kind of sandwiched between these two structures with wooden members on the inside and the outside. And you see that then in the facade of the project. Okay. So we think that this revaluation of heterogeneity that these examples engender really also suggest new avenues for contemporary construction. So, we're designers, we're architects, we're also very interested in the implications of this research in our own work, but also contemporary practice. So we've started to use some of the lessons from this research as kind of jumping off points for a series of, let's say, very, very early building experiments, prototypes. It's our studio in Providence, Rhode Island. And I think there's this question of how do you translate this kind of research into contemporary practice? How do we work with materials that are readily at hand here in our context in the kind of post-industrial city of Providence, materials from Home Depot? So, we decided to focus on just 3 very quick element prototypes to start, 2 columns and a wall. So this is the first one. This is a kind of column prototype, which is a mortarless stack of different materials of glulam block, glulam, concrete pavers, clay flutes that are tied together by a steel tension rod. It's very simple, right? It's the materials on a 12-inch module, and each distinct material is held in compression in the system, but working together. And I think there's a potential, I think, to define a different type of column, one that has a kind of playfulness of a kind of ad hoc construction, a type of construction that is able to incorporate things into it, kind of a mix of things, which is useful, if you're working in a context where materials are scarce or you're trying to kind of work with salvaged materials. The second prototype is another column. This one is made up of metal conduit elements and then polystyrene foam to make a very lightweight column capable of taking compression loads. So here, the steel is really there to take the vertical loads. There's a minimal amount of it, and there's the foam in the center that really acts like a spacer to space apart the steel elements and to keep them from bowing inward or outward. So the intention is really that the materials are complementary, right? It's their very difference that allows for their strategic combination. And I think we might think of broader lessons that come out of this, right? How might we combine low amounts of high-strength materials with high amounts of low-strength or maybe weaker or cheaper materials? Or how might we combine, let's say, low amounts of high-embodied energy with high amounts of low-embodied energy materials in contemporary construction? So how can you mix, right, to produce the performance that's necessary in a project? The last one is a wall prototype that's made up of 2 parallel stacks of materials, one concrete pavers, the other of wood, and they interlock. The white pieces that you see in the photograph are actually the result of, let's say, the empirical process of building this, because as we built it, the wall actually fell down several times, always failing at the corner. And part of it had to do with the geometry of the pavers, is that they tend to roll out of the corner. But Brett had this wonderful idea of actually starting to include a little bit of a fabric ribbon right into the wall and then pulling back the corner. So those are those white elements that you see. But we love these moments, right, where there's this combination of an empirical process and also an analytical process, and that there are these details that necessarily have to result from the pragmatics of the construction. Here's just a close-up. You see the wood scaffolding coming through. So I think maybe it's a way to conclude or to think about in conclusion by considering materials in combination rather than in parallel or monofunctional layers. There are likewise opportunities for increased efficiencies and performances across the assembly. Of course, we must also confront a set of deeply challenging questions in a project like this that are cultural, that are creative, that are ethical and practical. If we think about the examples in the atlas, many of them were developed empirically over many generations, and as a result would be very difficult to not only replicate, but also to rationalize, to calculate using modern analytical methods. So as a result, any kind of contemporary approach to material heterogeneity has to be reimagined through contemporary construction standards, engineering processes, material availability, and of course, cultural and labor conditions. We still have a lot of questions. I feel like this is the beginning of the project. I think one of them has to be, how can we really evaluate, quantify, and qualify the complexity of indiscrete, heterogeneous construction in order to really justify building this way in our current construction and regulatory environment. Of course, there's also conceptual and theoretical questions of these heterogeneous constructions and how this really inflects our more general design thinking. Maybe to conclude, I think heterogeneous construction is then a kind of methodological framework that is at once deeply historical, but also of critical contemporary relevance, and which has the potential to challenge our tendency to reduce construction to a series of received systems. The heterogeneous might instead be better understood as a body of knowledge that demands to be read, to be interrogated, and constantly reworked. Thank you.